All good? All right. Good afternoon, everyone. I am Oussama from ANYbotics. I'm in charge of the power and utility vertical within ANYbotics. I'm very excited today to be here on stage with ANYmal. I believe you have seen it already, but today the goal is to see what it can do, and maybe let's share some lessons that we have gathered from the field. So I just have one question. How do I move to the next slide? There is a clicker here. There is a microphone. There is light. There is a table. There is a bottle of water, an old coffee, but no clicker. Fantastic. I promise this one I will give it back. Thank you very much. All right. So, ANYbotics, we are a Swiss company, spin-off from ETH Zurich. So ETH, it's the MIT of Switzerland, top 5 into technology. And we have been developing legged robots for a while now. And we have spin-off from the university in 2016. So over this extended period of time, we have had nice achievements. We had, for example, the world's first robot, autonomous robot being deployed in an offshore facility in the North Sea with Tenet. We also have one of the first IP67 water and dust-proof robots being developed. And we also have the world's first explosion-proof robot, Adex and ISEX, up to zone 1 in hydrocarbon areas. So just a quick resume, not mine, but Robert's resume. And our goal is really to enable our customers to gather data even in the most difficult and dangerous areas, right? So that's also put us asking the question, why do we have legs, right? I mean, drones, obvious, a wheeled robot as well, but we know that in facilities, in oil and gas facilities, in power plants, in mines, sometimes it's difficult to fly drones or to have wheeled robot. You have stairs, you have steps, difficult terrains, so the legged configuration is the one to go with. But then we know, of course, those facilities have been built for us humans, right, with a very complex engineering. So in order to be able to collect data in the most remote areas, we have a reinforcement learning algorithm that teaches the robot where to go depending on our customer's requirement. So for example, in a recent deployment in a refinery in Europe, while we had to go a little bit, the stairs were a little bit too steep, so we took the stairs model, we put them in the algorithm, we taught the robot how to handle them, and then we're able to continue the journey there. Second, we have this LiDAR here. Our goal as well, of course, is to work fully autonomously, right? Because one of the challenges we're trying to solve is, of course, safe operations, but also fighting the workforce shortage. And there is no point in having every time an human operator handling one robot, then you cannot solve the problem. So this robot can work completely autonomously, fully autonomously, and it can navigate in very large environments. One of the enablers is this LiDAR, and we also have all over the place depth cameras to help the robot understand a little bit how the ground is doing, and it can adjust to this configuration. Then, of course, this is just a platform, right? The goal is to be able to to collect as many data as possible. So this platform carries standard a payload, right? With a visual camera, with optical zoom, 20 times photo and videos. We do have a thermographic camera, a FLIR one, an acoustic microphone, and then of course you can add whatever you want. You can add gas sensor, you can add a BLK laser scanner, radiation payload for radiation mapping, isodose card mapping, and so on. And then of course, you also need to have some processing of the data. So when you configure the robot, when you commission the robot, you can tell the robot, okay, look, you go here, and then you check the temperature of this specific asset. You're looking for hotspot. And if you, for example, you find the temperature above a certain level, then you go and you perform the second mission. If it's all good, then you move to the next one. And last but not least, of course, we all work in an ecosystem. There is no one, one hand cannot clap alone, right? So we're very happy to work with many of our partners, Yokogawa, Accenture, Cognite, and so on. We have an open API with an SDK that allows us to integrate with all of those partners. So this is ANYmal. This is the IP67 robot. It's not a prototype. We have over 100 robots deployed all over the place. Currently, we are shipping something like 5 robots a month. And this robot is CE certified for activities in Europe, FCC for North America, ANTEL for Brazil, and so on. It is completely water and dust proof. We have also software suite that can be used to remote operate the robot, to steer the robot. More than happy to show it to you afterwards in the booth, so you can also play with it. You will see it's very user-friendly. Of course, you need some connectivity, so it can work with Wi-Fi, 4G, 5G, LTE, and also completely autonomously. But you will see that connectivity, I think, it's a very important one in robotics deployments. So our activities are heavily focused on in the energy sector, mainly traditionally from the oil and gas field, right? Because we have these dangerous environments. Often you have offshore facilities, so the business case is easy to justify for. The safety aspect is also an important one. So it makes sense from an economic perspective as well as from a technical and health and safety perspective. We do also have more and more traction in the power generation domain. For example, with Siemens Energy, we're the scaling partner, or in the grid sector, where, of course, being waterproof robot, you can leave it in substations during the winter. And trust me, this one has seen the Swiss winter. So despite the global warming, it's still a challenging one. But of course, you also have activities outside of the energy sector, work in academia, construction, train inspection, a lot of train inspection, and of course, dangerous environments means also mining and metals. So what does that mean, being able to go everywhere to collect the data? So those are some data on what the robot can achieve in terms of mobility and navigation. So the robot is omnidirectional thanks to its X-shaped leg here. So it means you can take stairs on both directions. You can go on slopes. You can even overhang. But no, Maurice, can we show them the cool overhanging feature for pipe inspection? Basically, the robot torso will go really, really down on the floor, and then you can take control of the head, and then you can inspect pipes, right? For example, for thermographic inspections or visual inspection. Okay, all right. So now that you've had a quick introduction on the technology, let's maybe deep dive into the missions, some use cases, and then some lessons from our deployments in Adex environments. So how does that work? So basically, either you have a point cloud, right? You already have a BIM model or anything. You give it to us or you use it, and then you set up all the point of interest, all the assets that you want to inspect, and then you give it a reference value in terms of inspection, temperature or pressure for a gauge, or a frequency for sound, or LOL for gas, or whatever, and then you create a path, inspection path. And you can also define when the robot does those missions thanks to mission scheduler. If you don't have this digital twin, well, you can use the robot will map the whole facility, and then you can use it to navigate and localize. And one use case from many customers starts with creating a digital twin with the robot's LiDAR, either this one or a more advanced version of it. So you already generate value just by commissioning the robots in your facility. Typical use case range, for example, from condition monitoring to regular operators round. So for example, you send the robot to identify malfunctions after you have an alarm or a sensor problem, or you have a problem in your production or whatever. The robot goes there, tries to identify if you have temperature malfunction, or you have a too high pressure, too low pressure in a gauge. It detects for gas leakage, radiation, for example, when you do isodose mapping, for example, right, try to understand what's going on. And the advantage is that you can use it whenever you want, right? I mean, it doesn't have a vacation, doesn't have free time. So his job is his life, right? So you can really use it whenever you want. It's often used also for worker safety, and that's also one key aspect for our company, is really let's make sure that our robot can go everywhere where technology enables us, and if the technology doesn't enable us to go everywhere, let's push the boundaries of technology to make it happen. So nuclear environments is one of them. Explosion-proof areas is one of them. Outdoor areas, offshore areas. That's really our mantra within ANYbotics. The robot is often used for reality capture, where basically we can really collect detailed point cloud, and from that one you can generate BIM models, so you have digital twins that you can use afterwards to program missions with the robots. The robot has also been used in some chemical plants as virtual line walks. So for example, before going and sending engineers to inspect, you can, for example, use the robot, you can send it, and then you can validate what you want to inspect because you want to make it safer. So one example of use cases is, for example, offshore wind. I know in the US you're coming to it, but in Europe there is a lot of renewable activities, especially in the northern part of Europe. And there, of course, like for oil and gas offshore platforms, one key problem is those helicopter travels, right? You always need to send people, and then you have regulations. You need 2 pilots, you need 1 cook, 1 nurse, 2 engineers. You cannot travel everywhere every time, and sometimes you have accidents, unfortunately, with people dying, and you want to reduce it really to the strict minimum. So one thing is to deploy the robot offshore and then let it do all its mission either on a regular round or on demand. So really enabling this 24/7 presence offshore. And thanks to its multi-sensory abilities, and you can add additional sensors, well then, of course, you can really do a lot there. And of course, the business case is quite easy to find there. Another domain we're really pushing in the power sector, and we're improving there, is the nuclear sector, where the goal is, of course, to reduce people exposure to radiation. So all these RP related use cases are really pushed within our company, and we have developed now a dosimeter for our robot, as well as 3D gamma radiation abilities. And the goal there is, of course, to increase the uptime of the facility by limiting the shutdowns, and also by reducing the people's exposure to radiation. Now, talking about nuclear, well, there is also another important one, which is Adex areas, which is a very dangerous zone. Sorry, apologies. Which is a very dangerous environment, and we're very happy that 1 year ago we have released ANYmal X, which is our Adex certified robot. And this short video now will introduce you to the technology, and then we can deep dive into the lessons learned from over 1 year of deployment in oil and gas and chemical facilities.
At ANYbotics, we relentlessly pursue a safer and more human-friendly working world. Our robots join teams who run industrial plants to help out, uncover risks, and keep people out of harm's way. ANYmal X, the world's first EX-proof legged robot, is a game changer. ANYmal X now makes it possible for the oil and gas and chemical industries to automate routine inspections. Teach it once, and the robot will remember every task and every corner. Exceptional mobility and full autonomy ensure that ANYmal X self-navigates entire facilities and diligently automates precise inspection tasks in potentially explosive zones.
This ANYmal X is really cutting edge, really. On a platform, you need those agility because the areas are very cramped. You need to climb stairs. The floor could be oily, and the potential from a 4-legged robot is just enormous. And having it EX up to zone 1, that would really enable us to bring the robot very close to our process area, and that's where you create value.
Petrobras targets all opportunities to reduce exposure and increase reliability and productivity. For us, ANYmal X is a gateway to a new technological paradigm.
What got us really excited about ANYmal X? It's simple. It's the first X-proof quadruped robot. ANYmal X can close a technical gap, conducting automated inspections in a very complex environment with stairs and tight passages. And that's in combination with X zones. That's a novum.
ANYbotics and leading global operators are transforming industrial inspection. Become a partner and welcome ANYmal X on your team.
All right. So since we launched this product 1 year ago, we had a dozen of companies working with us as early adopters of this technology. So we had real-life deployments in operational setup. We had 4 of them offshore in all over the world, really in the 5 continents. We had 9 in oil and gas facilities and 2 in chemical facilities. So the goal of those deployments were really to understand what's the reliability of the system, what was the user experience, right? Because there's a difference between developing something in the lab and having users really adopting the solution. So we were really, really keen on learning what can be improved from the user experience. The goal was also to test robustness, because those are tough environments, especially offshore. So the fact that we can really have this operational deployment happening, it really helped us to really push the boundaries of our solution. Then, of course, also how do you integrate this solution within the different end customers' systems? Last but not least, how was the mapping doing in offshore facilities, for example? So as we're talking now, we have over 3,600 successful inspection points in over 500 missions that have been running, and it's still accumulating on a daily basis. So we really do have a very interesting and very healthy data set that really enables us to really constantly push the state of the solution. And I would like today to share with you some conclusions from our journey, because I believe this can be helpful for everyone interested into robotics in Adex zones. Well, one of them, well, of course, you need an Adex robot, because hot working permit, that's not a viable solution when it comes to autonomous robots. One very interesting learning was that, well, of course, we need a very thorough training and preparation done onshore with simulation, with pre-planning and so on, before deploying offshore. That's really an important one. Third, well, of course, you always also need internally within the customer, right, a very good collaboration between the onshore team and the offshore team to enable a smooth deployment once you're there. And the FPSOs, while the robot has to perform safely, especially when you have this pitch and roll of the platform, and they were very happy to confirm that ANYmal was highly capable in handling this situation. Then, from a vendor perspective, it was also very interesting to see that there is really a lot of support and service that is needed to really nail down the needs and then also to make the program successful. So we are very happy to have our field engineers that are completely trained to go offshore and to really support our customers until they can find the sweet spot in the missions and in the deployment. Then, of course, like any innovation project, always think big, start small, fail fast, and scale fast, right? So it was really nice to start first with small pilots, and then, of course, now we're completely scaling with over 500 reservations for ANYmal X in less than 1 year. And of course, while the biggest and most important element here is reliability, especially for unmanned operations, where we really need to constantly push and test the robot in as many operational setups as we can, so we can really make the reliability an exhaustive theme with our robot, because we always have new situations, we always have new setups, and we're always keen to onboard new partners or new infrastructures where we can test the robot and really improve it until we have the perfect solution for those environments. So, I hope you enjoyed this short presentation on legged robot. It's not flying, but still. And we do have some demo slots, and happy to meet you at our booth. And yeah, happy to take your questions. Thank you very much for listening to us. Yes, please. Yes.
If when the robot is under mission, excuse me, and the chassis gets damaged, exposure to electronics, is there an automatic self-shutdown?
So again, I couldn't hear the question.
Certainly. So if the chassis was compromised in an accident and it's on a mission and electronics were exposed, you've now compromised your ATEX certification. Does it have a self-shutdown safety mode?
Yeah, absolutely. So it's really, really hard to have the chassis damage. I mean, it's a very, very sturdy robot with a lot of protection outside of it, but you never know what can happen, right? Imagine you find yourself in this specific edge use case where the robot get damaged, and of course there are a lot of safety mechanisms that the robot will shut down, and definitely we will take the robot onshore and we'll send it back to Switzerland. We won't even leave it to our service providers, so we'll take it there and repair it, because if you have a damage to the chassis, then you really have a big problem there, and we don't compromise on safety. Thank you very much. Other questions?
Oussama, thank you very much.
Sure.
Please see him at 4:07. Let's give him another round of applause for a great presentation.
Thank you very much.